Hello and welcome back to a brand new video. Today we're gonna see how to convert a binary value to a decimal value. Now this video is going to be a mathematical explanation of this concept, and in my next video I'll go over the code to do this. So let's get started. But wait, before we get started, are you subscribed? Almost 96% of you that watch these videos are not. And I really request you to subscribe because it helps this content reach more people and aids my goal to spread code literacy. So if you still haven't subscribed, subscribe. The button's right below this video. And if you have already subscribed, here's a big thanks from me. You did a good job. Now anyways, back to the video. Let's see and first understand what a binary value is. So, a binary number is a number system that uses only two digits, 0 and 1. Each digit in a binary number is called a bit, and the binary system uses powers of 2 to represent numbers. The rightmost digit represents the least significant bit, while the leftmost digit represents the most significant bit. Now, what does this significance mean? It basically means that the rightmost digit has the lowest value in terms of converting it to a binary in terms of converting it to a decimal value, and the leftmost digit has the highest power of 2. I'll write that down to explain it much better. Alright, so let us imagine a binary number. Binary numbers could be of any length. I'm taking a 4-digit number here. Let's say 1101. Now within this number, the value of the rightmost bit, which would be this, would be the least, meaning this would be 2 to the power 0, and this being the leftmost digit, it's going to be the most significant, meaning its power would be 2 to the power 3, since each digit is a power of 2 and it increases as we move towards left. Now, how to convert this binary value to decimal? Let's see the general formula that we have for that. So that would be, I'm representing decimal using a D and I'll represent binary using a B. So decimal equals binary. Now this is 1 bit that we're talking about here. So that would be B n times 2 to the power of n. Now that is 1 bit. This and the next following bit would be b n minus 1 times 2 to the power n minus 1, and this would go on until b0 times 2 to the power 0. Now this would be our general formula, and in terms of converting this value to decimal, let's see how that would work. So now our decimal value for this particular binary would be, let's write that again here, 1 1 0 and 1. Now we are converting this to a decimal. Also, since we are talking about computers, our counting never starts with 1, it always starts with a 0. So this position would be 0, that means n0. This would be position 1, n1, and 2, and 3. So even if this is a 4-digit value, the index or the position of the leftmost bit would be 3, since it goes as 0, 1, 2, and 3. Alright, back to this. So now we have b of n, that would be this 1. So we'll write down 1 and multiply it by 2 to the power 3, since that is the value of n here, and then we'll add once again 1 into 2 to the power 2, then a 0, since b 2, this particular bit is a 0 times 2 to the power 1, and add further another 1 into 2 to the power 0. Now let's see what this equates to. So 2 to the power 3 is 8. Since we're multiplying with 1, we don't need to write that down again. So we'll quickly just write down the values of the powers of 2 plus 2 to the power 2, that is 4. And since this multiplied by 0, we do not care. We'll just write 0. And 2 to the power 0, as we all know, is 1. So upon adding these values, we get 13. Which is the decimal representation, and 13's binary representation would be 1, 1, 0, and 1. Let's write binary. If you enjoyed this video or learned something new from this, I highly recommend you leave a like down below, and if you still haven't subscribed, this is your call to action. Subscribe. I'll see you in the next video where we discuss the code for creating such a conversion from binary to decimal. Until then, goodbye.